Okay, so welcome to lecture 2, and this is on data presentation and interpretation. Okay, so actually the slides were prepared by my other colleague. Okay, but yeah, we continue. So we're talking about just describing data graphically. So we are still on chapter 2. Okay, so we should be able to construct frequency distribution tables by now because we already covered that. Okay, so we should be able also to construct and interpret a histogram, create and interpret bar charts, pie charts, and stem and leaf diagrams. Okay, so we should also be able to present and interpret data in a line chart and scatter diagrams. Okay, so why do we summarize data? Okay, so raw data actually can, data in raw form are usually not easy to use for decision making because it's just so distorted. You don't know what is in that data. Okay, so you need some form of organization, and that is why it is summarized. Okay, so we have different ways of presenting different types of variables. Just as you saw in chapter 1 that we have different types of variables. So for categorical data or qualitative data, we use frequency distribution tables, bar charts, pie charts, and Pareto diagrams. Okay, so for numerical or quantitative variables, we use the line chart, frequency distribution tables as well, a histogram, an ogive diagram, stem and leaf display, or scatter plots. Okay, so now these are different diagrams or ways of representing different types of variables. Okay, so for categorical data, it can be tabulated or graphed. Okay, so we use the frequency distribution table to tabulate categorical data. And for graphing, we use bar chart, pie chart, and Pareto diagrams. Okay, so we have an example, and we need to summarize that table. We have our different categories and the frequencies. Okay, so this is the frequency distribution table because you have your hospital unit and number of patients, which just represents the frequency. So in the cardiac care, there we have 1050. And emergency unit, we have 2245, and so on. So here we are able to summarize categorical data into a frequency distribution table. Okay, so for graphing, we use bar charts and pie charts. So actually, the height of the bars just represents the frequency or percentage of the category. Okay, so this is how we can represent our frequency distribution table of categorical data into a bar chart. Okay, so what you see there, we have a scale in the vertical from 0 to 5,000. Of course, you take consideration of your frequency, what numbers are within your frequency. So here we have from 0 to 5,000, and in the horizontal axis, we have the different categories. So we have the cardiac care, emergency, intensive care, maternity, and surgery. Okay, so each bar, the bar will represent the frequency. Now what you notice here is that there are gaps actually in between the bars. Okay, so this is actually the difference between a bar chart and a histogram. A histogram will also look somewhat like this, but there are no spaces in between the bars. Okay, so this is a bar chart. It has spaces between the bars. Okay, so we move to a pie chart. For a pie chart, what you notice there actually is that it is represented by sectors of a circle. Okay, so the sectors are actually commonly known as the slices. Okay, and usually these are represented by percentages. So you get the total number of patients, which is the frequency, 8,801.19. Okay, yeah. So then to find the percentage, of the first of the cardiac care, we're just going to have 1,052 over the total frequency, which is that, and then we multiply by 100. What we're going to find is 11.9, which is just equal to 12%. Okay, so you do the same for the other hospital units. You find the percentages as well. Okay, so that is how we construct a pie chart. So you divide the circle according to the percentages. You know everything, the whole circle is 100%. So according to the percentages that you get, you can allocate each unit, you can allocate a sector or a slice to each unit. Okay, so Pareto diagrams are actually just constructed from a bar chart. So for Pareto diagrams, what you have to do is that you have to sort the bar with the highest frequency. Okay, so there's some sorting as you can see there. Maybe let's just go back. So you're supposed to sort in descending order from the smallest to the highest. So we're given an example. 400 defective items are examined for cause of defect. You have bad weld, poor alignment, missing part, paint flaw, electrical short, cracked case. Okay, so the total there is 400. Then find the percentages. We find the percentages. So for the first one we have, we have 223 over 400 times 100, and this should give you this percentage, which is 55.75. 55.75. Okay, so that is how you get the percentage, and as you can see, the percentages were found for all the source of manufacturing error. Okay, so after that, okay, so you're actually supposed to start with the smallest and end with the longest bar. Okay, the shortest to the longest bar, and you just be putting the dots on the middle of each bar, Okay, so you put the dots on the middle of each bar and then connect the dots. So this is what is going to be found. Okay. Okay, so now we move to graphs for time series data. Now, time series data is just data that has been collected over a long period of time. Okay, so actually we have seen time series data before. On typical example is on under 5 cards for our little brothers and sisters. Okay, so this is some data also from 1990 to 2006. Okay, that is the magazine prescription. The magazine prescription by year. Okay. So this is an example of time series data. Okay, so we move to numerical data representation. So of course, it can be tabulated on a frequency distribution table. Okay, so we already have done this. So maybe let's just revise with this example. A manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. Okay, so those were the temperatures collected. So we first sort the data. We have that. Then we find the range, 58 minus 12. We get 46. Okay, so you have to make sure that you have your calculator beside you. Okay, so that is the 46, and we've been taught to use 5 as our number of class intervals. So now we have to compute the width, which is just the range over number of class intervals. So the length is, the range is 46 divided by 5. We have 9.2, round it up, and you get a 10 as your class width. So now, you also have to determine your starting point. Just have to make sure that all the data set falls between 5 intervals. Okay, so here, chose to start with 10. So have 10 but less than 20, because to this 10 we add the class width, which is another 10, so we get 20. So have 10 but less than 20, 20 but less than 30, up to 60 but less than 70. You now then count and assign the observations. Then from the frequencies, okay, so there's something that we did not do previously. Okay, so now we're now going to discuss how to find the relative frequency. Okay, so the relative frequency is actually calculated from the frequency. So for the first class interval, you get the frequency divided by the total frequency. Okay, so for the first class interval, the frequency is 3 divided by the total, which is 20. 3 divided by 20, and it gives you a 0.15. 0.15. So this is actually the relative frequency that you see there. For the next class, for the second class interval, we have the frequency is 6 divided by the total frequency, which is 20. And what does it give us? 26 divided by 20, 0.3. Okay, so this is how you get all the relative frequencies. Okay, so to get the percentages of each class, actually when you have the relative frequency, just multiply the relative frequency by 100. Okay, because we already have the frequency over total, just multiply by 100. So for the second class, to get the percentage, we have 0.3 multiplied by 100, and this gives us what? 8 as our percentage. For the first one, you have 0.15 multiplied by 100, it will give you 15. So just get the relative frequencies and multiply by 100. Okay. So that's on how we get the relative frequencies. Okay, so we move on. Okay, we now move to a histogram. We saw that we can actually represent quantitative data using a histogram. Okay, so a histogram is just a graph of data in a frequency distribution table. Okay, now what we notice is that there are no spaces between gaps. Okay, the interval endpoints are shown on the horizontal axis. And on the vertical axis, you can find the frequency, the relative frequency or percentage. Okay. So that is an example from the previous data that we already summarized into a frequency distribution table. We have 10 but less than 20, 20 but less than 30, 30 but less than 40. So what you have here, your lower limits will be, so your lower limits will be will be on the horizontal axis. Okay, then one thing that you should note here is that even the way we have constructed our class intervals, there are no spaces. You have 20 but less than, 10 but less than 20, then the next is 20 but less than 30. So there are no gaps in between our class intervals. That is why we are able to directly construct a histogram from our data. Okay. And in this case, this way of representing data, the class intervals, actually our class limits are also our class boundaries, because there are no spaces between one upper bound to the next lower limit. Okay, so that is why we are able to construct a histogram directly from the frequency distribution table. If we had a class interval such that maybe we have 10 to 19, then 20 to 29, and 30 to 39, in that case, there are gaps in between the last horizontal, the last upper limit and the next lower limit. What I'm saying is this. If we had 10 to 19, then 20 to 29, this is just an example. Okay, this is just an example. Then we say 30 to 39. In this case, you see that from 19 we go to 20, but we can have maybe 19.5, 19.1. Okay, so there's spaces, there's a 1 here. Okay, and then after 29 again, we come to 30. So if we had such a way of describing our class intervals, then we needed to close them. Okay, but there will be no need in this case because we have represented our data in that form. Okay, where we have no spaces from the first upper limit to the next lower limit. Okay, so as long as we have represented our class intervals like this, then we just go straight and represent our data in this manner. Okay, so that's how you can just construct a histogram in Excel. Okay, and we'll do that. All right, so we now move to the cumulative frequency distribution. Okay, so far we know how to construct a histogram, we know how to put the percentages, we know how to calculate the relative frequencies, but then let's see how we can find the cumulative frequency. So the cumulative frequency is just the frequency of each class interval. Okay, let me just say how the frequency accumulates for each class interval. So for the first class, we just get the frequency will be also the cumulative frequency. Okay, so we have it. Okay, so we have the classes there. We have the first class. Okay, so maybe some people will be confused. Let's do this. So we have 10 but less than 20. Then we have 20 but less than 30, 80 but less than 40, 40 but less than 50, okay, and so on. So the frequency here we have 3, 6, 3, 6, 5, 4. Okay, and so on. And for the other classes, so because there's no space, I'll not 50. So that's just the last class. So 50, but less than 60. Okay, actually I'll table. Alright, so these are the frequencies. Now I'm just going to show you how to find the cumulative frequency. Okay, so what we do here is that for the cumulative frequency, okay, let me just shorten it. Cumulative frequency, I'll just say CF. Okay, so the cumulative frequency. So for the first class, we just pick the frequency of the first class, which is the 3. So this will be its cumulative frequency. For the second class, we add all the frequencies up to the second class. Okay, so up to 6. Okay, so therefore we have 3 plus 6, that's 9. So 9 is the cumulative frequency for the second class. For the third class, you have to add all the frequencies up to the third class. So you have 3 plus 6 plus 5. Okay, so 9 plus 5, which gives you a 14. Okay, then for the fourth class, you have to add all the frequencies up to the fourth class. That is 3 plus 6 plus 5 plus 4, and it gives you 80. And for the last class, you have to add all the frequencies up to the last class, and this will give you 20. Okay, so that is how we get the cumulative frequency, the cumulative frequencies. Now to get the percentages, again, what we do here is that you get the cumulative frequency and you divide by 20, multiply by 100. So for the first one, 3 over 20 by 100, 0.15. The second one we have 9 divided by 20 times 100, which is the 45. Okay, and 14 divided by 20 times 100 to give you 70. And the last one, you have 20 over 20 by 100, it will give you 100. So that is how you get these values that you see there. Okay, we now move to the ogive. So for the ogive, again, there you just have your limits, which are your lower limits. This time we don't have bars, we just have the dots, and you connect them with a line. Okay, we now move to the stem and leaf diagram. This is also a very simple way to see the distribution. Okay, so in this case, in this way of describing data, we have to sort the data first, and then separate the leading digits, which are the stems, and the last digits, which are the leaves. So in that data set that you've been given 21, 24, 24, 26, up to 41. So this is a 10 okay, let me just say a two digit stem and leaf plot. So what you do for 21, 2 becomes your stem, 1 becomes your leaf. For 38, 3 becomes your stem and 8 becomes your leaf. So the whole data set will be represented in that way. So that will be our stem and leaf plot. Okay, so for numbers with 3 digits, we just round off the third to the second digit. Like 613 becomes 6 becomes the stem and 1 becomes the leaf, because 3 is less than 5, so we can't get a 1. 776, 7 becomes the stem, and to the 7 we're going to add 1 since 6 is greater than 5, so it becomes 8. Okay, and there we have 12 becoming the stem and 2 becoming the leaf. So the whole data set will be represented by that. Okay, we can also look at the relationship between variables. So for categorical data, we use cross tables, and for numerical data, we use scatter plots to see the relationship between two variables. So we now look at scatter diagrams. Just need to know, given any two variables, you can get one to be your horizontal axis and the other one to be on your vertical axis and plot the data. It's more like just having x, y. Okay, so you can plot like that. Then look at the relationship. You can have that or this. Okay, so these are linear because they are more like they form a straight line. Now this one is increasing, but the other one is decreasing. The other one is curvilinear because it forms some kind of curve. Okay, so some relationships just hard to define. Just conclude that there is no relationship. Okay, so we've come to the end of actually the last thing that we're supposed to do is just to see the relationship between two variables, two categorical variables, and that is represented by cross tables. So with the cross table, you are able to see the relationship between one variable and the other. Okay. Okay, so we can also have a multivariate categorical data. This is represented by side-by-side bar charts. Okay, like these charts there. So, yeah. So make sure your data is well represented. It's very clear and actually defines the purpose of your representation. Okay. All right, we have come to the end of our lecture. We have come to the end of our lecture. So the next time we meet, we're going to go into lecture 3, which is a measure of central tendency. So start looking at how to find the mean, the mode, the median for both grouped and ungrouped data. Thank you very much.